Let's now look at how we prove the second theorem that we added to the events decrements, which is to say the element V that we're trying to find exists in the array from interval P up to r-1, where r-1 is because the current value of F at index r is greater than V. And if you look at the diagram that we showed before, because currently f of r is greater than V, so we change the value of q from q into q prime, where q prime is equal to r decremented by 1. So we are saying that the theorem that we're trying to prove is to say V must exist, because we know by the sorting property that the V cannot exist to the right of the index of r, so it must exist to the left of r. And now the theorem we are trying to prove says that V must exist in the array F between P and r-1. And to prove this, we will actually apply the same knowledge as before. We want to first use the fact that the array is sorted, and we want to use the fact that V does exist in the whole array of F. And we want to use these two facts to prove that the theorem holds. Let's go back to the Rodin, and let's go to the proving perspective and see how we actually prove it. And let's switch to the proving perspective. This is what we want to prove, and we first search the relevant hypothesis. First, the sorting property, and second, V does exist between P and Q, the two indices in array F. So let's add these two hypotheses, and first of all, let's expand the membership over here. So this expression here says V must exist between P and Q. So there must exist some index x such that f of x is equal to V. So let's expand this membership, and this is exactly what we just said. So you are supposed to figure out why this expression here is equivalent to this predicate logic here. You are supposed to figure that out and convince yourself why this is the case. Okay, let's go on. Now, this line here is the instantiation of the fact that there exists an x. So now we say x maps to V is in F. In other words, f of x is equal to V. Okay, so before we proceed any further, let's do another expansion on the membership in the goal. So now, the only difference is, instead of saying P up to Q, now we say P up to r-1. So there exists an x. So let's expand first. So there exists an x such that x is between P and r-1, and x maps to V is in F. So now we want to say this x we talk about is exactly the x that has been instantiated in the hypothesis already. So we will instantiate x as x. So this x here is bound to the x over there. So we instantiate. So now we want to prove that x is in the range of P up to r-1. In other words, x is greater than or equal to P, and x is smaller than or equal to r-1. For the latter, we can actually reformulate it in the following. So x is smaller than or equal to r-1. It is equivalent to saying x is less than r. And let's see how this x less than r expression might be useful to be proved from our hypothesis. Let's have a look at here, this line here. We agree that V can be substituted by the fact that x maps to V is in F. So this V here can be substituted by f of x. So we have f of r larger than f of x. And we can see here, this is the greater than relation. and this is a smaller than or equal to relation in the context of some implication. And this does give us some motivation to use the modus tollens rule. Just imagine that if we put f of r here and f of x over here, and eventually, and also we put r and x here, eventually by applying the modus tollens, we can actually negate both the consequence and the antecedents. And if we negate an antecedent, we will get something that will entail trivially the goal. That's how we're going to do it. Okay, so now, as we said, we will instantiate this by r, and we instantiate this guy by x. Once we have done the instantiation, so now you can see that we have r less than or equal to x as the antecedents. So in order to apply the negation of that, we first have to prove the negation of the consequence. Okay, let's apply the modus tollens. Okay, this is the negation of the consequence, and to prove this, this will be trivial because you can see that f of r is greater than f of x already, so it will just blow away. Let's try again. Okay, in this case, we may have to add some typing information for f. So let's search the hypothesis and to give more information to Rodin about the type of function f. Okay, let's give it there. And now, it does blow away. That's good. So now the last, so as you can see here, this is the negation of the antecedents because we have already proved the negation of the consequence already. So that's the first step of the modus tollens. So now we are in the second step of the modus tollens. We're using the negation of the antecedents to prove the goal. Okay, so now we actually see a pattern of not P or Q, and this is equivalent to P implies Q. Let's rewrite it, disjunction to implication, and we have just another occurrence of not P or Q. So let's apply the same rewriting rule again, disjunction to implication. Now, because we are sure that this is the case, so we can trivially prove the antecedents and then use the consequence as another hypothesis to prove the goal. This is called the modus ponens. So let's apply the modus ponens here. So this antecedents is trivial to prove because that's simply the typing information for R. So it will just blow away easily. Now, for this guy here, we have another implication to prove because we are sure this is just another property that's trivial to prove because of the typing information for variable x. So we will apply the modus ponens here. So now the antecedents is trivial to prove. You will just blow away. Now, what remains to be done is this guy here. So now we have R larger than P, and so remember what we are trying to prove is X is actually less than R, and this is exactly what we get. So if you look at this expression here, P is the lower bound for X and R minus 1 is the upper bound for variable X. So we only need that two pieces of information. So let's get rid of the irrelevance hypothesis. So this first guy here talks about the lower bounds for X, and this guy here talks about the new upper bound for X. So these two together should entail the goal easily. So let's try, and it just blows away. So now we have completed the second theorem that we have added to the events decrements. And if we go back to the events B perspective, we have discharged all the proof obligations at refinement level 1.